Hi guys, welcome back to the Common Lisp series. Today is day 21 and this is the first video of 2026. So welcome back. So today we will start a series of videos on network programming. Not many, maybe 3 or 4 or 5, and we'll do different things in the space of networking. So I want to start with the classical hello world of networking, which is a basic TCP Echo server. So in this video, we'll only create the server and we will look at the client and other things in future videos. So today the objective is to create a simple TCP Echo server. So an Echo server is basically a server which just receives connections and just returns whatever messages comes to the over the network. So let's get started. If you're new to network programming, socket programming, so this is kind of the standard guide. I recommend you check it out if you're not heard of this Beaches guide. It's talking about how to do socket programming in C and the basic hello world and the important functions and so on. So one of the simplest programs that you can do is basically write a TCP Echo server where we have a server that's going to just open a TCP socket and wait for connections and just going to reply to new connections with whatever text is being sent, right? So if you want to do this kind of simple example in Common Lisp, how do we do it? What is library? So we use usocket. So there's a universal socket library for Common Lisp. It's a very old package, a very standard package. It, as usual, it papers over differences between different Common Lisp implementations, the usual. Now you can check out the API documentation of usocket where it talks about the core functions, which are exactly the same as the the core functions as it is in C, with some convenience wrappers on top. You can also look at the quick Lisp documentation file to get the API. So let's look at the code. So I have a simple version right here. So we are going to here import quick load usocket and body threads, which I've used before. And we are creating a package called server, usual stuff. So we just have two functions, handle connection and server. Let's just go through this. So basically in this server one function, we are going to do our open our socket, basically start listening because we want TCP socket, right? So you don't have this step for UDP. For TCP, you have to do a listen. So here in this case, I'm just using port 8000 and 0000 means all interfaces, not just localhost. In your, I mean, usually it doesn't matter if you're doing your development locally, you can just use 127.0.0.1. That would be the same thing in this particular scenario. So once you've done this, we are now going to start a loop where we are going to wait for incoming connections. And basically this connection is when there is a new connection, you're going to accept the connection on this socket, right? And then we have a new connection and that's basically like a new client, right? So if there are 5 clients connecting simultaneously, each of them will have a separate connection. And then because we want to continue doing this thing, we're going to spawn a thread where we're going to handle this connection in a separate thread. And then we continue this loop and we just wait here for new incoming connections. So for client that is already connected, basically we want to handle the connection. So basically we pull out the stream. So there's a socket stream of that connection. And then we're going to read stuff from that stream. So this is like the usual, if we have used this readline function before, it's the same semantics. Until we reach end of file, we're going to read. And what we're going to do is we're going to simply write back the same thing that we read with this prefix you said. And if you see here, what we're just using the format function, which we've used many times. Usually we use the second argument as t, which means it's format to std out. Instead here, the destination is going to be this string, right? So basically, once you do it, there's one more thing you need to handle here, which is basically to force output. Otherwise, output is buffered and it won't go. So you won't be able to see the response immediately. So once you do this, you have this loop, right? So basically, you're just going to wait for entries, and for every entry, you're just going to send back the same text, essentially. And when you're done, so this loop will break because if you reach end of file, because the connection is closing, and then we just close the connection on this side, right? So let's look at this. So I mean, I've been running it before, but let me run it again, and you will see there's a small problem here. I'll explain what this is. You can see that the condition was raised, which is usocket address in user, right? That's because I was just running this earlier, the same code, the same function, and I just cut it, and that didn't really clean up that socket. So now normally you just throw an error when you write this kind of program in C is very common, but because Common Lisp is giving you this condition system, you can, the programmer of this usocket library has added a condition and case to handle this particular scenario. So basically we know that in this situation, That's because your port or host is busy. They've given a condition which you can then activate as a user and do something inline without actually having to rerun the code or change the code. So in this case, I basically want to use a different port, right? I have 8000 in my code. So if I hit this is basically prompting me for a new port. So let's say I use 8001 now, and it's going to then continue with that code with the new value. So I didn't have to go in and like change my code here, right? And I didn't have to rerun the code or anything. The program started, it paused in the middle, and then we just did what we wanted to and continued. So this is the power of the conditions, common Lisp condition system. Now the server is running. So I am just going to do netcat. So netcat is a client for this kind of communications. I'm just going to use and connect to 8001 because that's where it's running. If you see here, now there is a new client. That's what it shows. And I can say something like hi, and you said hi. So this is coming back from the server. So there's no logs here, so it doesn't really show up, but you get the idea. Now I can, of course, open another terminal and do the same thing. Let's just connect again. So there are like two connections. So if I say I from 2, so basically this is being handled by the same server, but from a different thread. Like we saw, a new thread was spawned, and you can see here there's a new client being connected. So there's a new thread being spawned here to handle this one. And they can both go in parallel, and that's not a problem. That's how servers work. You can have many clients connecting to this TCP server. So I'm just going to cut it, for instance, and if I cut it, you should be able to see that we are closing a client and we are done. You close both the clients, but the server is still running because you can have more clients coming in and so on. So this is where I simply, hit Control C and relate to an interrupt from Emacs. I can continue if I want, but I just want to close it, right? So I just want to abort the thread. So I'm done. So I have aborted the thread, but like you saw, if I try to run this again, because we didn't really clean up the ports correctly, right? So we didn't have a cleanup function being called for this. We just cut it, right? So the right thing to do is actually handle interrupts in this function properly, but let's do that later. So this is the basic version of this code of creating this server. But turns out that if you go through the documentation, there is a nice socket server function which seems to do exactly what we want. So this is a higher level function. So instead of doing the lower level API with us creating the socket using listen, accept, and all of this, it's basically giving a higher level, simpler API. So let's look at that code, right? So I have the code for that below here. So this is the new code, the new version. So interestingly, you'll see that I have done a quick load of usocket server, right? Which is a different system, but I'm using the usocket package, right? So let me talk about this again. So we're using this usocket library, right? But if you go to the repo, you will see in this repo. So this is one repo, it's one Git repo, right? But you have here multiple systems ASD definition file. So if you go here, you will see there is a def system usocket server. This is the new one that we're going to use. And if you see here, there is the default one, right? So the one we did first. So the point is there are multiple systems, but there is only one package, which is usocket. So in this package, you also have the other function that we're using, right? Which is socket server. So it's somewhere here, right? This is a function we're using. So this package.lisp is defining what is being exported, but this function is actually only defined in the usocket.lisp file, where we say this is usocket, right? We need usocket server. So if we go back to the system, maybe that will become very clear. So we're talking about the usocket server system. So in this system definition, there is this file called server that it is loading. So if I open server.lisp, which has to be somewhere here, you see that we are doing in package of usocket, right? So that's how this works. So there is some function here which is being defined, but it's also going into the same package called usocket. So that means we have to do a new quick load to get this functionality. If you don't do this line, this will error out. It will say no symbol called socket server found. But when you do quick load this system and then you use this function, so this symbol in the usocket package, which is the same package that we have been using so far, it works, right? Anyhow, the point is this is the function which is the new server, and here we are basically just calling socket server with our IP, port, and the handler function. So this is the new handler function. And then so there's some more arguments. I've put in this argument for multi-threading equal to true. You can see the full list of arguments in the documentation page. So there is all of these arguments that you can set. For example, you can change the protocol. So easy way to run a UDP server would be to just use this version and then change the protocol and so on, right? So there's a bunch of flags here. Now I'm setting multi-threading to because I want multiple clients to work. And the only thing to note here is we have a new handle connection function here. And if you see this function, it's exactly the same as before. So there's a small difference. And the difference is that we don't need to do the, the connection stream and the socket closing part, right? So that is already done for us. So this handle function is getting the stream as an argument, which you can directly use. And at the end of the function, you don't have to do any cleanup because this socket server function is going to handle that file. So you can see it is a much simpler way to create a server because you're just focusing on the handler function, what you actually want to do with the data, with that connection. And you're not really worrying about doing all the low level calls. So that's very nice. So I can just try to use this. So I'll have to load this. So let me rerun. I'm loading all of these new functions and then let's run server 2. So this may not work because like I said, the port might still be under use, right? Understandable. Let's just use a different port. So I can click this. You don't have to use the keyboard, you can use a mouse. And let's use the port 8002 this time. And it's starting up. There's no log statement like before because I was earlier like logging manually new client and start a TCP server. So we don't have that here, which is why you see it's silent. I go back here and I start this and let's say I again, and you have this same handler running. So like I said, there's no logs here, right? Because we don't have a way to do that. And we're done, right? So that's the idea. And it's the same concept. It's just a simpler API. I'm going to interrupt, I'm going to close this. It's the same thing we have done earlier, but now it's just a lot easier and simpler to do. So with this usocket library, you can also do the other part, the client part, but I am not going to cover that. You can easily follow this documentation. You should be able to do based on what I've just shown you.